This chapter is going to be talking about fractions, more complicated operations with fractions that have polynomials in their numerators or denominators. And as always, we're going to begin by basing it on arithmetic. If I tell you the fraction 8/12, I'm pretty sure all of you know that in reduced, that is 2/3. And I think that we've also explained that the reason behind this is because we can think of 8 as 4 times 2, and we can think of 12 as 4 times 3. And because 4 divided by 4 is 1, it equals 2 times 3. This is the same reasoning behind the fractions we talked about in the last chapter, where 8x squared y over 12xy squared reduces to 3x over 4y, because that reduces. One of the x's cancels out, leaving one on the top. One y cancels out, leaving y on the bottom. The difference is that in this chapter we're going to be talking about polynomials, which are the sum of monomials. So the first thing I want to make sure that you understand is that if I take, for example, the fraction 6/7, I could think of 6 as 4 plus 2 and 7 as 4 plus 3, but I can't cancel that out because obviously 6/7 does not equal 2/3, and the reason is because these things are added together. And when I have things that are added together, I can't cancel out parts of them. It's important to remember to think about this 4 plus 2, it's the whole number, and 4 plus 3, it's the whole number. The addition in the middle of it makes dividing the 4's not work, because it works here because multiplication and division are inverse operations. But as soon as I got that plus sign in there, I can't do that anymore. The things I like to stress in the very beginning, and we will be talking about, is the PPP principle, and that is put your polynomials in parentheses, because no matter how much sense that whole idea of 6/7 not reducing to 2/3 makes to you right now, visually it's going to look like it should cancel and be very tempting. So for example, let's talk about, let's get into some examples. Let's say 3a plus 3b, here's a polynomial, over 3a plus 6. I think probably based on what we just talked about with the 6/7 example, you know that these 3a's can't be canceled out. When I say put your polynomials in parentheses, if you do this in the first step and understand that you cannot cancel out anything that's a part of what's inside parentheses, then you're far less likely to make the classic mistakes that are made in this chapter. So then you might say, okay, so can I simplify this fraction? And yes, we are allowed to simplify things that are multiplied together. So what I want to do is see if I can break this down into factors that multiply to give the numerator and the denominator. In other words, the first step in all of these problems will be to factor the numerator and the denominator. There is a step in between this called finding restrictions on the variable that I'll address at a later date. For now, we're going to focus on just the simplifying. So if I'm going to factor this goes back to all of last chapter, where we know the whole flow chart. We're going to first look for a greatest common factor. If I have 2 terms, I'm going to look for a difference of squares. 3, try the try. 4, group. Watch out for when the coefficient of the quadratic term is not 1, etc., etc. I'm pretty sure you know how to do this. So this numerator has a GCF of 3, leaving a plus b in the parentheses. The denominator has 3 times a plus 6. So now the 3 is multiplied with a plus b, so it can be canceled out. The 3 is multiplied by the a plus 6, so it can be canceled out. Notice that's as far as I can go. I can't cancel out the a's because they are parts of a polynomial. Look at another example. If I have n plus 4, actually, the way you'll see this problem is just n plus 4 over 4n plus 16. And the first thing you want to do is put your polynomials in parentheses. So n plus 4 can't be factored because it only has 2 terms and it's not a difference of squares. So I'm going to look at the denominator. 4 is the common factor, and ooh, how convenient. I have n plus 4. This whole number is the same as this whole number, regardless of what I plug in for n. That's what we're looking for in algebra. What's true no matter what I plug in for the variable. Any number I plug in for n, plus 4 will always be the same as n plus 4. The reason I wanted to do an example like this, though, is that when everything cancels out on the top, you need a 1. Because n plus 4 divided by n plus 4 equals 1, not 0. So it equals 1 over 4. If this whole problem were reversed, I could do the whole thing quickly without explaining the steps. Oops. That's the problem with going quickly. These cancel out. I could put a 1 in there, but I don't really need it because 4 divided by 1 is the exact same number as 4. So, in this example, I need the 1. In this one, it's okay to omit it. So now let's look at another kind of situation. If I have x squared plus 16x plus 64, and on the bottom I have 64 minus x squared. And before you get tempted to cancel out parts of these polynomials, we're going to put those polynomials in parentheses and instead factor. You all know that this is x and x. The signs are the same. They're both positive. The numbers that multiply to 64 and add to 16 are 8 and 8. Now, notice the x squared comes last, so the x's, this is a difference of squares. X's have to go here. I'm going to have 2 different signs. And square root of 64 is 8. So you may say to yourself now, okay, x plus 8 and 8 plus x, that's not exactly the same. However, whatever I plug in for x plus 8, for example 2, 2 plus 8 is the same as 8 plus 2. The order in which I add numbers does not change their sum. That's the commutative property of addition. But the bottom line for you is when things are added together, if they're in a different order, they're still the same number. X plus 8 is the same number as 8 plus x. Y plus 4 is the same number as y, as 4 plus y, etc. So my final answer here is x plus 8 over x minus 8. And nothing, they are not related and cannot be canceled. But I can come into a situation where if I start out with 5 minus x, for example, and I have x squared minus 10x plus 25. I'm going to put my polynomials in parentheses. 5 minus x can't be canceled, but I can factor, can't be factored, but I can factor this. And I'm pretty sure you know what I'm doing here. Now, is 5 minus x the same number as x minus 5? Because if it's not, we really can't cancel it. Let's try by plugging in a number for x. Let's do 2. That's nice and easy. 5 minus 2 over 2 minus 5. Well, clearly they're not the same number. However, they are related. And when I divide them, I get negative 1. And in fact, you'll find out no matter what number I plug in for x, if I have got things subtracted in a different order, although they don't exactly cancel out, they do divide to give me negative 1. So the way that I go about this is I cancel them, and I leave a little negative sign right in front of the fraction bar. In fact, I didn't quite get that in the right place. So it goes right in front of the fraction bar. And once again, when everything cancels out on top, we need a 1. So the answer to this problem is 1 over x minus 5. Another thing that can sometimes help you in these problems is what I like to call the textbook trick. Because most math textbooks like things to cancel out. Not always. And this isn't a mathematical thing, because if we were ever using any of this in the real world for solving problems, it wouldn't be set up like this. But the truth is, for the problems that you're going to be doing, if either the numerator or the denominator is easier to cancel, to factor, as it is in this case, the denominator is, do that one first. So this has a common factor of 2b, and what's left in parentheses is 4b plus 3. Now, on my top, I have a coefficient of my quadratic term, which means I need to guess and check based on numbers that multiply to give me this and this. So the textbook trick is, if that's a factor in the bottom, try that first. So 4b times what would get me 4b squared? So it's times b. And 3 times what will give me negative 6? Minus 2. So that's going to be my first guess. And in fact, it works because the outer is negative 8b and the inner is positive 5b, and that, the positive 3b, and that does get me to negative 5. So that's what we call the textbook trick. In all of these problems, though, the factoring can sometimes be tricky, but that's what you're doing. You're just going to factor and then cancel. The hard thing is to remember that if I have x plus 2 and 2 plus x, that's the same number. When I divide them, they equal 1, so they cancel out. If I have x minus 2 over 2 minus x, that's almost the same number. Not quite. We cancel them out, and they give us negative 1. If I have x minus 2 over x plus 2, or x minus 2 over 2 plus x, whatever, they look like they should be able to cancel out, but they don't. That's as far as you can go. And that's because if you plug in any number for x, the fraction that you get would not reduce, or at least it wouldn't reduce in every case. So that's our video for today.